Perfect. So let's go dark. So today we're going to talk about the hidden cost of dependencies. We're going to talk the questions you should be asking about dependencies. We're going to talk about the tools that can help you to find your answers for the questions you're asking, and also hopefully trigger some ideas and plant some seeds for you to move forward with. So who's standing in front of you? Well, my name is Mattias Karlsson. I'm a partner and senior architect at a consultancy in Gothenburg Sweden called DevConf. I'm also a Microsoft Developer Technologies MVP, which means, well, I won't fix your Visual Studio, but I know a bit about that. I'm also an avid open source citizen, so I do a lot of DevOps tools. I like the Unix philosophy and multiple tools. So I'm a tool guy. I've been doing console applications, well, since the 80s. And in one way or form, they will end up in your containers or in your lambdas or in your functions. Like they're always back in some way or other. And least but not least, I'm a husband of one and father of two. So dependencies. Well, we're going to talk mainly about our third-party dependencies. And they can come in many shapes and forms. They can come in projects, like you link in your own projects, but you can also have source dependencies. We can have developer assets of different kinds, assemblies like NuGet packages and things like that, and tools that is part of our chain. So the agenda for today will be that we will investigate, we will then act, and we will report. So if we start with investigate. A regular .NET solution looks probably something like this. You will have a solution file. You will have some kind of library or something, and hopefully you will have some code that executes. You will have often a NuGet source config with which sources you're fetching your dependencies from. It will have maybe a global JSON which you have to have repeatable builds to pin the version of .NET you're using. And you will have a project file which has dependencies. So if we look at the .NET project, this has changed a lot since, well, .NET 2 was JSON, and then we switched back to MS in 3. But it's lots, like if anyone has been in .NET as long as I have, it used to be a lot more. Now you just specify what differs. And here you specify things like which SDK I'm building. So this will differ if it's an Azure function, or if it's a web application, or if it's a SQL project, or something like that. You will have the target of your framework, so if you're building from .NET 7 or .NET 6 or .NET 8 or whatever. You will also have your dependencies. So here you specify the dependencies of your project. So if you look at this kind of project, I have the sample project here, and you can see everything there. So all the tools I will be showing today are free and open source. I'm not selling you anything or sponsoring anything. Some of the maintainers probably like, well, it will just be burning if you use them, but I will show some useful tools which can help you in it. So let's start by looking at the project we had. So the dependencies look simple. We just had 2 dependencies in our CS port file. We can see here, we analyzed. So if we do what we usually do, a .NET restore, then we will restore dependencies and fetch them. Then something happens. So let's do a .NET restore. It will fetch, look at all our resources and all our feeds, and restore those projects. If we then analyze, we will see this. Microsoft has hidden everything. Oh. So you have a lot more dependencies than you think, because your dependencies will have dependencies, and those dependencies will have dependencies, and they might have dependencies. So what looks like the hidden beneath the surface, you will have a lot more dependencies. And you will also see, if you look at the project, you will get all these kinds of files and things added. And the same, like if you build, you will also get even more files added. So we look. So if you look after restore, you will notice an obj folder magically appears. And it has all your assets defined in a JSON file. So all your dependency graph will be defined there. So that's the way you can peek down and see what you have there. It will also have things like what feeds did you fetch your dependencies from. You can do things like have lock files, like you have them, so you can lock down versions, but this is a good way to be able to inspect what's there. Also, if you see when you build, you will get the bin folder where you will have the target. So if you target multiple frameworks, you will have one folder for each target framework. And you will also have a dependency manifest here where you can actually peek what's dependencies for that, because they can differ for each target. You will have the assembly you built or exe or whatever, or if you're building debug, you will also have the debugging symbols. So there's a lot of things that happens that are hidden from you, like if you just look at the project file. So let's look at a couple of tools that can help us with that. How we can invest. A good tool is one called Depends. It will help you visualize dependencies in your command line. So you install it as a .NET tool. So you will do .NET tool install depends. If you just run it, you will get this kind of help file. But if you run it with a project file, you will actually get something like this. And this is really useful because you can actually go through all your dependencies, but also go reverse. You can see what dependencies depend on this. So this is a good, simple way for you to know more about your project. What your, what's the burden? And if someone well, do I have this dependency in my project? You can actually investigate with this tool, .NET Depends. Because you all know what something happens, like if someone has a malicious code, how do I find this version? Well, I can easily browse around and get a good view of my project. So it visualizes dependencies, depends. You install it as a .NET global tool or local tool in your project. And you just launch it with .NET and depends. And it's available on NuGet. It's free and open source. You can get it. Another good tool is a tool called Snitch, also free. You do .NET tool install Snitch. If you just run it, you can get the help. But if you run it on a project, what this will do, it will actually analyze. So if you have a solution with multiple projects, it will find out which dependencies are transient. So here you can see that you can remove from the user project to dependencies because those are already defined. So if we have my console application that brings in the core library, I don't need to have also those defined. So if we see in let's make it bigger. We have the core. If we look at the tool and its project file, it also has these, but it doesn't need those because those are brought in. And this means if you can remove those, you will only need to version those in one place, which means that you have lesser merge conflicts, or you will have also easier, like if I update here, I know that will be updated. If you don't do that, this might override and cause issues. So that's a good tool. And just to repeat myself, it identifies unnecessary transient dependencies, dependencies that will be brought in by other dependencies regardless. There are scenarios where you want to have them, like if I want to pin a specific version, well, then I want it. But this can identify, like, do you really want that? And especially if it's your own project, when you're linking, you want to define it in one place. And it's easy to install. Just .NET Tool install snitch, and it will fetch it from NuGet. So now that we have found out things that we can do, how can we, as a developer from command line, keep our things, how can I act to see that my dependencies are up to date and things? So a couple of tools that will help us with that. So there's one called PackCheck. You just install it with the .NET Tool install PackCheck, and it has a simple usage. You can either specify a solution file or a project file. So let's run it on a project file. It will show you all dependencies that are out of date. So here we'll demonstrate this dependency exists with a newer version. So you don't have to go to NuGet yourself or your internal feeds or whatever. It will notify you. It also, on the same note, my preferred tool, and just the same thing, is a tool called .NET Outdated. You just do .NET Tool install .NET Outdated tool. If you run it, it has the similar. You specify a project file. It has a lot of things. It has more bells and whistles. So if you run it, it will do the same thing. You can see that for each target framework and for each project, it will list these are the dependencies that are out of date. And you can just do a -u, and it will actually update all. You can also do things like --include if you just want to update one specific dependency. Usually that's if I want to commit, I usually want to update one dependency, commit that change, because if I want to test or if something broke, I can just do a treasure. You can also do --exclude to say I want to update N unit, but not this analyzers or something like that. So that's how you can act on. So we had a PackCheck, identifies and updates outdated assemblies. Just do a .NET Tool install PackCheck, really simple from command line, and you launch it with .NET PackCheck. And it's available on NuGet, open source and free. We had a .NET Outdated, which also just does the same thing. It's .NET Tool install .NET Outdated -tool, and you can launch it then as .NET Outdated. And you can both, if you're on a machine with all .NET tools, you can use -g to install it so it's always available globally on your computer, or you can install it in your project if you have a tool manifest. So now, some important part, especially if you have C-level discussions, or if there's a big outbreak, do we use this as dependencies? How do we know what dependencies we have? And that's often something we want to have as either we report as a build artifact, or we send it to some system, or something else. And one of the tools for this you already seen. Full disclosure is one of the tools that I've written. It's called DPI. And it visualizes and reports dependencies. So it can either, if you want, just print it out to console, as we saw here. So you install it by doing .NET Tool install DPI. And once it's installed, you can do .NET NuGet, which is one of the dependencies support. And if we do example here, you can see you get a table. It can also output to Markdown, so you can actually get something that you can do to if you have a static site generator or something, you can actually, or your GitHub Actions, summary reports, you can actually just send this as an artifact and it will be part of your run. One nice thing it also can do, it is going to actually report to Azure Log Analytics. So something that we do in all our projects is that for all in our build pipelines, we run this tool, it will output the tables. We had it in our build logs, what dependencies, what for that build, but it will also report to Azure Log Analytics. And having things in a central place is really powerful, because that depends, regardless if my pipeline is running or if I have the depends running, I can do advanced queries. So like I have a project called BRI here, and then I can do like the custom query language against millions of projects or rows or anything, and see, well, for this project core devlead/BRI, I want to see what are the dependencies in that project. And this will run through all the builds from the last 30 days, regardless of which system, and it will fetch that we have, these are the .NET tools that were installed in that project. This has a build script and it has these tools. We can also see that in this project file, we have all these dependencies for multiple frameworks. So this is .NET 7. If we go down, we will also see probably .NET 8, all this long. We can also do things like through the whole organization, what are our top 10 packages? If we just remove this. So here we do a summarize for all our projects, uniquely like a distinct count, fetch all dependencies. So this is like, we can have thousands of projects and see what are the most popular NuGet packages we can fetch. So if we want to query, do we have this dependency? We can do something like that. And things like the top 10 reports or whatever. So that could be a good thing, like just like you're going to use this tool, but having a tool that can report to somewhere else means you can query and do things across, and you don't need access to the actual thing. So if you have a breach or something where do we have this dependency wherever, or this was poisoned on NuGet, you can do things like which version, well, this version is used. Well, for all projects across the company, give us those projects that use this version, which is really powerful. So .NET Tool install API if you want to try it. It's open source. It will only be a hassle if you use, probably raise issues, but free to use it, free to contribute to it. And as I say, you can also output to Markdown if you want something to attach to your build log or something. And this comes down to something which is, you will probably hear more and more, and will be a requirement, is called SBOM. It's not a bomb, it's a list. So it's a software bill of materials. And this is something that will be more and more required of you as an organization to have. Because if something happens, there's like EU law that says like within X amount of time, you will need to be able to see how you are affected. And a big part of this, and this is something which is really important that many developers forget. So with SBOMs, there's two major standards. There's Cyclone DX, which is from the OWASP, if you like the security project. So if you have sent that list, usually it's just like top one, SQL injection, those are the people behind that list. They have this Cyclone DX format. There's also the SPDX, which is from the Linux Foundation, and it's also an ISO standard. So you can read more about Cyclone DX on there, and you can read more on SPDX on there. And there's different versions and things like that. So to do this, well, you don't want to handwrite JSON or XML or something. You need a tool for it. There's one tool officially from Microsoft called SBOM tool. So let's run that. It's .NET tool install Microsoft.sbom. Well, it's Microsoft naming. It's long. It has all the bells and whistles. My main problem with this is that it doesn't have sensible defaults, but it can do anything. So if you run it across a project, you can essentially run it as the project output, and it will create an SBOM file for you. So it has its own format. So it will create an SPX 2.2 file for you. So it creates specs 2. It's not the last step, but it creates a format that's accepted and standard. You can install it in your pipeline or locally by doing .NET Tool install Microsoft SBOM .NET Tool and run it like .NET SBOM Tool. And it's available on NuGet, and it's really long, so but take my word for it. The OWASP community has also a tool called Cyclone DX, which creates Cyclone DX SBOMs. So let's look at that. You install it by doing .NET Tool install Cyclone DX, which you can almost remember. And it has a lot of bells and whistles, so let's run it. One thing is that the default is just specify the project file. So that's a pretty good starting point. So if you look at this, it will just be a JSON file where all your dependencies is specified. It will have which version, vendor, but it will also have things like your own assemblies will also be here. So you have a full bill of materials of your. Another tool to do this is called Covenant, and it's my favorite. It will actually generate both Cyclone DX, SPX. It has its own format, and it can also do HTML. So let's take a look at that. So you .NET Tool install Covenant, then it's installed and ready to be used. It has a few arguments. You can specify just the path to where you want to investigate. You can specify the output file and in which format. So let's try an example. Now we're creating its own format. So let's take a look at that. The standard is its JSON file. It will also do things like what kind, but also the licensing. It will create hashes of files and things like that, which can be really useful. And as I say, it can also create HTML, which is really good because when your manager comes, he will let's see. He will love because you can get this nice report to him where you can click, you can see all the licensings, you can also see which dependencies these dependencies have. So I really like this tool. You can see all the licensings, you can see all things where it's unknown, and this is good because then you can see if you have a policy, we only need these licenses, you can focus on the one it couldn't resolve automatically. But you can also spot things like this is a preview, should we be using that? And so it's really good to get a high-level thing. You can give this to the manager, like this is a report. If you have some kind of investigation, or if you need to something like a third-party auditor or something, you can just give them this. They don't need access to systems or anything. But it can also be something part of your build system. So you have an artifact in your log that you can just look like, what did I do with this build? So you do .NET Tool, install Covenant. You do .NET Covenant, and you can fetch it there. Let's see, perfect. So here I want to need to be able to see more what happens in your project. And I think you look at things like it looks simple, like the first project we looked. If you look at this, it's just 2 dependencies, but it can be a lot more. It can be that dependencies have dependencies. And that's the really question you should ask, what am I? And if someone gets the question, do we have this library? And your first answer can't be, I don't know. You should be able to have that answer at your fingertips. So if someone comes to you and says this, you can just say, here it is. And if you ship something to a customer and you know which version they're running, you can report somewhere else. If you report to either a file that you archive, or if you report to something like Log Analytics, or if you report to another third-party system where you can query it, it's powerful because you might not be able to, if you've been breached, it could be that your main build system might be down because you were breached. Then if you have a third-party witness where you can query everything, then you can see, oh, it started happening here, it was this version, and you can actually be safe. Also, like that system doesn't need to have access to your system. So you can actually report in your build pipeline without things needing to be there. You can also have tools like the DPI tool running in your build pipeline to visualize things in your log. You can do things like a Covenant tool where you can both create an SBOM, you can also create reports, and it can also be used to actually convert between the different SPX and Cyclone formats, which means that if you have an auditor, he might say, I need it in Cyclone DX. Then you can convert to Cyclone DX with that tool. And this is really powerful if you have these single-purpose, like Unix-like tools, which has a good purpose and really easy to get them into your pipeline. It's not like you have this. There are really advanced tools, but one advantage is that also you as a developer can also run these locally, which means that before you do that push, you can do .NET outdated and see, well, I have dependencies. Let's take care of those first. So at the same time, and there's no extra effort because it's a tool. It's just a second to run it. So all the tools and the presentation is available here. I'm available as dev lead in most places. So you will find me on, well, all the places almost, like Blue Sky, Mastodon, and GitHub, and my blog is devlead.se. So thank you. Any questions?